So with continuing these notes, we're going to have a little bit more complicated things going on in the denominators, and we'll see what happens. So find each sum or difference. Problem 1. We'll rewrite 4 over 3a minus 6 plus a over a plus 2. Now the hope is to end up getting things that combine, and I cross my fingers, and on this left fraction I factor 3 out and change it to a minus 2. So before I can even combine things, I want to make sure things are factored as possible. Now I was hoping to see a plus 2 because this would mean that it would be less work. Now I'm going to draw an arrow here in red, meaning later on maybe this becomes an optional step in how you would organize it, because you could just sneak a plus 2 here and there, but I think that's going to look pretty sloppy based on the amount of space I've given. So I would strongly recommend that as we try to get a common denominator, we're going to rewrite 3 times a minus 2. Now this has a plus 2, but my left fraction doesn't. But I can fix this fraction on the left by adding an a plus 2 in the denominator. And I'll extend my fraction bar to cover that distance. But I've just divided this value on the left by a plus 2. I've totally changed it. So to make sure that I'm not changing it, I'm going to write a plus 2 over here. And really what this means is I've simply multiplied this whole fraction by a value of 1. So I have not changed this value as long as I multiply the numerator and denominators by the same thing. I'll move over here, and I will deal with this fraction next. I'm going to write the numerator and the denominator. But now I'm going to multiply it not just by a minus 2, but also by 3. So I'll multiply this by 3a minus 2, and this by. So I got 3a minus 2 in both locations. So that now when I go and I try to simplify and combine these fractions, I will not distribute anything in the denominators. Doing all that is extra work that I don't need to do. So I'll write a large fraction with 3a minus 2, a plus 2, and obviously order doesn't matter here if you end up switching them around. In the denominator, I will distribute 4 to a and a 2, and then I will distribute 3a to a, and I can do that in a single step now, and then write minus 6a as this 3a hits that 2. In the numerator, sometimes it's nice to deal with the denominator first. I'll write this in a different order because normally we see the plus sign first. I have 3a squared showing up. 4a minus 6a gives me minus 2a plus 8. Now, it's possible we're done, but we should check to see if this can factor. And I'm looking for the factors of 24 that add up to negative 2. Well, 1 and 24, or negative 1 and negative 24, but that doesn't work. 2 and 12, negative 2 and negative 12. And I'm tempted to say that 4 and 6 works, but I would have to have a negative 6 times a positive 4, and that result would give me negative 24. So without getting all complicated, right now this problem up top is simplified. We cannot factor that entire numerator. I also take another look at the 3, negative 2, and 8, and none of those values can be factored out either. So the idea here is that in order to add these up, I have to have common denominators. Problem 2. So let's look at this. H minus 2 over h squared plus 4h plus 4 minus h minus 4 over h squared minus 4. So step 1, let's see how this factors out. H minus 2 on the left, and then the denominator I'll turn into h plus 2 squared. And I'll go ahead and I'll show that as h plus 2 squared for now. Minus h minus 4 over, this is a perfect square, where I get h plus 2, h minus 2. Now if you're not able to recognize these as special factoring problems, then pause this video, go review an older chapter, or seek me for some extra practice. Now, over here on the left side, I like this h minus 2 business. I like this h plus 2 squared. But what this needs that it doesn't have is the h minus 2 part from the other fraction. So I'm going to put that in parentheses and multiply this whole thing by h minus 2 over h minus 2. Now, both of those parts match up over here. But what you'll notice is the exponent of 2 needs to be showing up over here for us to combine these fractions. So next I will continue writing my subtraction symbol, and I'm going to write h minus 4 all in the numerator, but I'm going to put this in parentheses for what I'm about to multiply this by. I rewrite the fraction, h minus 2. But instead of writing an exponent here, I want to make it clear to anybody that looks at this later on that I'm really multiplying it by h plus 2 over h plus 2, so that there's no confusion there. If you leave parentheses out, it is inaccurate, because if I didn't have this parentheses here, this would distribute incorrectly. So now I want to combine all these since I have the same denominator. And here's where you can get a little bit flexible with the steps that you might show, but you might want to be kind of cautious. So I'm going to first outer inner last this thing. So I'm going to write h squared minus 4h plus 4. And I'm not explaining where that's coming from, because hopefully that's understood now. Now here's where I'm kind of cutting a little bit of a corner. This minus is really going to have to get distributed to everything. So I'm going to write h squared negative 4h plus 2h gives me minus 2h minus 8. But I'm going to keep this in parentheses so that I don't screw things up. I think that distributing that in the meantime would be kind of a mistake and really encourage bad habits. And then down here, I'd like to see h plus 2 squared times h minus 2. Now I'm going to distribute h squared minus 4h plus 4 minus h squared, and I'm just flipping the signs on everything as that minus gets distributed, and I'm going to rewrite the whole denominator, and then I'm going to look for things that can be combined. H squared minus h squared goes away. 2h minus 4h gives me negative 2h. 4 plus 8 gives me 12 over h plus 2 squared times h minus 2. And then I'm basically done, but it's nice to see a factor get pulled out so that I write negative 2 times h minus 6 over h plus 2 squared h minus 2. Due to the length of these problems, I will leave this one at 2 examples. And really, if I were to list out the steps, it looks like this next one's pretty confusing. That's not 21, that's an L. That's an L, and that's an L. But if I were to try to list out the steps, it's like you factor things at the start, because maybe it ends up just really simplifying nicely. And once you have the denominators factored, then you're going to find the least common multiple. Then you're going to multiply it by basically 1, because if you multiply something by x over x, you're multiplying it by 1. And that's how I would do these. Good luck on those. Once you do a couple in your notes, you can see me for accuracy, and we'll make sure they're feeling okay. Because typing these in may be pretty darn tedious in Wolfram Alpha, or not crazy involved, but it's going to depend on the presentation of the problem.